Hello, Peter Newman with you. This week in AHRI Insight, we're looking at spraying stress weeds. Obviously, we've had a very dry start to the growing season in large parts of Western Australia and South Australia and Queensland as well. We have stress weeds in the paddocks, and we're looking to provide you some information on killing those stress weeds. So we dug up some old research done by Dave Minke and John Moore at the Department of Ag and Food. They did it in 1995 or thereabouts, and they were having a look at all the different effects that the seasonal conditions can have on the herbicide rate. Now, before I look at that research with you, I'd like to just have a think about what happens in the plants. I've drawn here the cross-section of a leaf where we have our cuticle, our epidermis cells, palisade cells and mesophyll cells. So we're spraying herbicide onto our plant, we're putting a droplet on that leaf surface, and we're trying to get it in through that leaf surface into the cells where it can then be translocated. Now, what happens when we have warm, dry conditions? The plant, instead of having a normal thin cuticle like we have here, it makes a very thick, waxy cuticle. So why does it do that? Well, it's trying to keep moisture in. It's trying to keep moisture in the leaf surface. So guess what? A thick, waxy cuticle also keeps moisture out. If we have our droplet on the leaf surface, it's harder to get that droplet through the leaf surface. Now, this is one of the biggest factors that affects the lethal herbicide dose of stressed weeds. So there are things we can do. We need to keep in mind this cuticle is not a plastic bag. It is more like tiles on a roof, layers of wax layered on top of each other. So there are pathways through a waxy cuticle. It's just much harder to get the herbicide in there. We can get the right adjuvant and wait for the right conditions. Now, what happens if it does rain and the weeds freshen up? It is good. They start growing again and they get fresh, but this cuticle is still very thick on the leaves the plant has then. So if you go spraying immediately after rain, yes, it gets a little bit easier, but we are still trying to penetrate a thick, waxy cuticle. In the ideal world, if we can wait until some new leaves have emerged, if the growing conditions have improved, the newer leaves will have a thinner cuticle and herbicide uptake can just about go back to normal, and we can get susceptible plants again. Hard to wait for the right conditions. We might wait and it might get dry again, and so there's no benefit. But it's just a reminder that once the plant makes this thick waxy cuticle on the leaves, it stays there and the plants never go back to being as susceptible as they once would have been. So the research by Dave Minke and John Moore, they looked at lots of different things, but moisture stress seemed to have the biggest effect. What they did is they did some trials using a rain out shelter to remove half of the rainfall from some plots. Then they used that rainfall to irrigate other plots. Then other plots had normal amount of rainfall. So they had low, medium and high moisture. And then they did a log sprayer across it with glyphosate. They'd sown wheat as the weed that they were looking at. They looked at the effect of moisture stress on glyphosate efficacy killing wheat. And what they found was where there was low moisture, it took 2.9 litres per hectare of glyphosate 450 to kill 90% of the population. So the ED90 is the effective dose to kill 90% of the population. 2.9 litres of glyphosate under moisture limiting, moisture stressed environments. Only 250 mils per hectare of glyphosate to kill wheat where there was plenty of moisture. So more than a 10-fold response in the glyphosate rate. And it really mostly comes back to what I was talking about over here. We've got that thick cuticle. It's very hard to get the herbicide into the plant. And once the herbicide is in the plant, it's growing very slowly. It's not translocating as normal, and it doesn't move through the plant as well as normal. In this research, they also looked at the effect of relative humidity on the day of spraying. So they had 2 trial sites at different locations that experienced very similar seasons and growing conditions and had similar plant size at both sites. The only thing that was really different was the relative humidity on the day of spraying. Where it was dry at a relative humidity of 30%, it took 440 mils per hectare of glyphosate 450 to kill 90% of the population. Whereas where there's higher relative humidity, it only took 270 mils per hectare to kill that 90% of the population. So relative humidity helps on the day of spraying. Higher humidity is good, but it only helps a little bit compared to that big effect of moisture stress on the plants. So unfortunately, with stress weeds, there's only so much we can do to kill those weeds. We can get the adjuvant right, we can wait for rain, and in the ideal situation, we can wait for more fresh leaves to grow on the plant so we can get that herbicide uptake. It's very tricky in these dry seasons. I guess we will expect some surviving weeds in a lot of situations if it stays dry. So then we need to think next about what we are going to do with those weeds at low cost in these years where we're trying to reduce our spend, and perhaps a harvest weed seed control tool like chaff lining might be a really good thing to adopt. So we've also put together some information on chaff lining over on the WeedSmart website, so check that out as well. But for more information on spraying stress weeds, take a look at AHRI Insight.